So in this example, a researcher wants to see if a weight loss program is effective. She measures the weight of 6 randomly selected women before and after the weight loss program. Is there evidence that the weight loss program is effective? Test at the 5% level. So the first question you have to ask yourself is this a hypothesis test or a confidence interval? Since it talks about is there evidence, that actually is what you look for to see that it is in fact a hypothesis test. Then you want to see if it's one sample or two sample. It talks about selecting women before and after. So that looks like there's two samples, plus you can see there's two data sets. So there are two samples here. You have to decide if you're dealing with mean or proportion. Usually you look for words like mean. There isn't one in this case. Or look for words like proportion. Again, there's not one in this case. But in this example, you can kind of see you're talking about weights, and so that makes more sense to be means. Proportions usually come from things that are counted. So this looks like it's going to be means. So we have a two-sample hypothesis test of means. We now have to decide is it an independent or paired test. So one thing we also notice is that we took women before and the exact same women after, which means that this first weight of 165 actually will have a bearing on this weight of 143. So they are actually paired together and they are actually dependent. So we can now say this is a two-sample paired t-test. All right. So the first step of every hypothesis test is to state the random variables and the parameters in words. So in this case, we have weights before and weights after. Those were what we measured. So we measured the weights before and after. It actually says the word measured here. It doesn't matter which order you put them in, but let's say we make the weights of a woman before the weight loss program is X1 and the weight of a woman after the weight loss program is X2. That would mean my parameters are means. So we'd have the mean weight of a woman before the weight loss program and a mean weight of a woman after the weight loss program. And the symbol for mean is mu. So we have mu1 and mu2. If you want them the other order, that's fine. There's nothing that says this has to be the order we're dealing with. As another reminder, in a paired t-test, we actually deal with the mean difference. So that is actually mu1 minus mu2. That's the mean difference. So that gets us to the second step of every hypothesis test, that is to state the hypothesis. So again, there are two hypotheses in every hypothesis test. There's an HO, the null hypothesis, and an HA, the alternative hypothesis. So let's talk about what is HA. What are they trying to prove? Is there evidence that a weight loss program is effective? So effective would mean, in this case, since it's weight loss, we want to lose weight. So we want the mean before to be bigger than the mean after. So we want mu1 to be greater than mu2, which means we want mu sub d to be positive. So mu sub d would be greater than 0. HO again is your claim that you actually assume is true, and that's always equal. The last thing to do is write down your alpha level. They asked to say test at the 5% level, so alpha would be 0.05. All right, now the next step of every hypothesis test is to state and check the assumptions. In a paired t-test, you have two assumptions. The first one is that you have a random sample of pairs. So in this case, we would have a random sample of 6 pairs of weights of women was taken before and after a weight loss program. So you actually want to think of it being one sample with these pairs together. So it really isn't a two-sample test anymore. It really is considered a one-sample test with these pairs. We actually know that this is checked because if you look back at the problem, it says that we randomly selected the women. So therefore, it is that assumption's been checked. The second assumption in a paired test is because we care about that mean difference, we're going to look at the differences in what we measured. So it's not the population of each individual one, it's the population of the differences in the weights of women before and after the weight loss program is normally distributed. So we actually don't care about the individual weights, we just care about the difference. So it's more thinking about how much did they lose. So if I looked at before and after for this first person, I would find out that that difference is 22. So that person lost 22, and that's more important of their weight loss than their individual weights. So to figure this out, we're going to look at the normal probability plot. Again, this looks, well, not again, but if you look at this, it looks like it's somewhat linear. One dot's a little off, but the rest of them all look like they fall on a line. If the normal probability plot isn't conclusive, you can look at the histogram. Looking at this histogram, it does in fact look kind of bell-shaped. And then also look at the number of outliers, and there is only one outlier in this data set. So we can assume that the distribution of the differences in weights is normally distributed, and therefore all the requirements assumptions are satisfied in this problem. Requirements, assumptions, I call them assumptions. All right, so let's go on to the next step, which is the test, statistic, and p-value. So we have these values. Again, what we really care about are those differences. The differences would actually be x1 minus x2, and it's always that order. As a reminder, we call it before x1, and we call it after x2. So we got to find those differences. So we're just going to subtract these numbers. Subtract the first numbers, you get 22. Subtract the next numbers, you get 21. 181 minus 156 is 25. And so forth down the list. 24, 16, and 21. Then you're going to use some technology, whether it's the TI-8384 calculator or Excel, doesn't matter what technology you use, to find your mean of these differences. We now kind of ignore x1 and x2. So we're going to find the mean of the differences. We call that d bar because it's the mean of the differences. And the technology tells us it's 21.5. You also need the standard deviation of those differences. So we'll call it S sub d to note that they come from the differences. And your technology tells you that's 3.15. And we need to know n, which is the number of pairs. We had 6 pairs. The formula for a paired t-test is d bar minus mu sub d over s sub d over the square root of n. So d bar is 21.5, but what's mu sub d? So as a reminder, that's what HO is useful for. HO assumed mu sub d was 0. So over here in this formula, we can actually say that this is 0. In most cases, that is 0. Then we put in the 3.15 in the bottom, divided by the square root of 6. And you do this calculation with your calculator, and you find out this is about 16.779. Then you need to get the p-value. So the p-value is the probability that the t you calculate is, in this case, we go back to our HA. Our HA was greater than, so our p-value is also greater than. So this should actually match your HA, unless you're in a not equal to HA, and then things get a little different. But otherwise, that symbol should always match your HA. You're going to again use some technology. Again, I don't care what technology you use, and you come up with 6.83 times 10 to the negative 6. If you are using the TI-83 or 84, this would be TCDF 16.779, and then your upper limit is 1e99 infinity because you are shading above, and then your degrees of freedom is 5. Remember, the degrees of freedom is n minus 1, which in this case would be 6 minus 1, which is 5. All right, so now we're at our conclusion. What we do is we use the p-value to determine if we're unusual, and what determines if something's unusual is your alpha level. So going back, our alpha level was 0.05. If our p-value is smaller than 0.05, then we can reject HO. In this case, our p-value is in fact smaller than 0.05. So since the p-value is less than 0.05, which is the alpha, you're going to reject HO. That's fine to say, but now we want to interpret it and let people know. So at the 5% level, There is evidence. If we're rejecting HO, then there's evidence that HA is true. So there is evidence that, what did HA say? Let's go back and look at our HA. HA said mu sub D was greater than 0, which means that people did lose weight. So that would mean the weight loss program is effective. So there is evidence that the weight loss program I apologize. So the weight loss program is effective. As a side note, I just want to make the comment that just because it's effective doesn't mean you should now run out and use this weight loss program. There are some questions you should ask yourself. Is it safe? How much does it cost? How long does it last? How long did it take to lose the weight? Because if it took 3 years to lose 22 pounds, that might not be very useful. Those are all questions you should be asking yourself. Plus, also remember that this was only done on women, so you cannot say that this weight loss program is effective on men. We only know that it was effective on women because that was the only ones in our study. All right.